Hi, this is Mrs. Bolin with your notes for 5.1. We will be learning how to graph equations that are written in standard form. So first of all, just to review from our previous content, question number 1 on the warm-up, is this linear or nonlinear? Well, remember, linear can be in the form y equals mx plus b with y's and x's and some other numbers. This one has an exponent. So this one that's not equal to 1. So this one is non-linear. If that exponent was on the 2, totally fine. 2 squared is 4. We can do that. When the exponent is on our variable, we know that it's not linear. Okay, question number 2 says solve and graph. So remember, for these ones, we're going to subtract the 5 on both sides to get the x by itself. X is greater than negative 11. So different teachers will have you graph different ways. I usually have my students put a 0 in the middle, put the 11 on the negative side. This one will have an open circle because it's not equal to under there, right? And x is greater than, so we go to the right. You can also use the secret shortcut where you, as long as the letter's first, you can turn that sign into an arrow and it tells you what direction to go. All right, question number 3, it says find the angle measure. So if we know that 2 angles are equal to each other, we can get rid of the parentheses, we can get rid of the little degrees, and we can go ahead and solve. So I'm just going to ignore the parentheses for right now. I like to look for wherever the smaller variable is. So 15x is smaller than 21. Technically, the variable is the same, the coefficient on the variable. So I'm going to subtract 15x on both sides. So I get 8 is equal to 6x minus 10. I'm going to add 10 on both sides. Remember, we always look for the x and we see what's being added or subtracted. Then we do the opposite. That's the inverse operation. It cancels it out. So I have 18 is equal to 6x. If I divide by 6, oh yeah, you can still kind of see that. If I divide by 6, it cancels off the times by 6. So we get x is equal to 3 for problem number 3 on the warm-up. Problem number 4 is for a solution to this line or this equation. So this is the x value, this is the y value. This time it doesn't even matter because they're exactly the same. You're going to put the 4 in for x and the 4 in for y. So 4 equals, and you can't really see it because I just wrote on top of it, but there is a negative right there in front of the x. I'm going to make it a negative 4 plus 8. So I'm going to say, is 4 equal to, well, 8 take away 4 is 4. Is 4 equal to 4? Yes, that is true. So yes, it is a solution. Okay, we're going to go through the notes pretty quickly here because I think it'll make more sense once we jump into some problems. So first of all, just knowing what the x and y intercepts are. The x-intercept, I'll scoot this over a little bit, is where the line crosses the x-axis. The value of y for the x-intercept will always be 0 because it's right on the axis. It's not up, it's not down, it's right there. The y-intercept is wherever it crosses the y-axis. And note that the x value will always be 0 because it's not to the left, it's not to the right, it's just right there. And I need to put my phone on mute. Oh dear. Okay, one of these days I'll learn. Okay, and then I was just trying to scroll to get that to move. I have to move it with my hands. This technology stuff, you guys, I have been teaching since 2001 is when I started teaching, and I had a chalkboard. So this is kind of different. So x and y intercept. A horizontal line is different than just that one point, which is the y-intercept. Okay, a horizontal line can be graphed with a y equals equation because it tells you the value of y is always a certain value. If you have a vertical line, it's going to be an x equals. The value of x is always equal to a certain value. Please do not get those confused with the x-intercept and the y-intercept. Sometimes we might say like y equals 3 is the y-intercept, but really that's the value of y, but the intercept is given by a point, okay? And you should, instead of saying y equals 3, you can say y dash intercept equals 3 or something like that. Okay, so this will make more sense once we start doing some problems. So let's jump into it. So for question number 1 in the practice, this says use intercepts to graph the linear equations, label the points corresponding to the intercepts. So do you remember I showed you that in order to find the x-intercept, the value of y was 0. That's a super easy point to plug in. So I'm going to plug in a 0 for y. Okay, so I'm going to put a 0 right there. And so I'm going to say 3x plus 4 times 0 equals 12. And I'm going to show you a shortcut on the next problem, but I just want you to understand what we're doing. Okay, so 4 times 0 is 0. So 3x plus 0 equals 12. Well, anything plus 0, that just goes away. So I have 3x equals 12, divide by 3, so x equals 4. The x-intercept is 4. So I'm going to find 4 on the x-intercept, or sorry, on the x-axis, and I'm going to label this point. This is when I go over 4, up 0. Okay, now I'm going to find the y-intercept. So for the y-intercept, remember that where it crosses the y-axis, the x value is 0 because it's not left or right. It's right on the y-axis. So the x value would be 0. The y coordinate has a point, but the x would be 0. So we're going to plug that in for x. So now I'm going to take the same equation. Let me switch colors here just so you guys can see. I'm moving to something else. So I'm going to put a 0 where the x is. So I'm going to go 3 times 0 plus 4y equals 12. Excuse me. Remember when we multiply by 0, we just get 0. And when we add 0, it doesn't change it at all. So essentially, we can kind of ignore that part. Excuse me, because anytime we multiply by 0, it makes that whole part of it equal to 0. If I'm adding 0, it doesn't change it at all. Okay, so I have 4y is equal to 12, and I'm going to divide by 4 on both sides, so y is equal to 3. Okay, remember that's a point. That's just the y-intercept. That's when x equals 0, y equals 3. So I'm going to put a dot right there. And the coordinates for that point would be go over 0 and go up 3. Okay, so that's the coordinates. And then I'm going to connect the dots. Okay. And that's what your line would look like. Okay, this kind of seems like a kind of a long process, huh? So my secret shortcut, I'm going to show you guys. Sorry, my hair is really fluffy today. I'm going to show you guys a secret shortcut. Okay, so look at problem number 2. What I like to call it is the cover-up method. So it's not really mathematically valid, but essentially it's what we're doing. So if I'm putting in 0 for y, that whole y term ends up disappearing because y is 0. Anything times 0 is 0. 0 plus anything doesn't make a difference. That 3x stayed 3x. Okay? So what I do is I say, well, assume we're going to put in a 0 right there. That essentially goes away. So look, when I cover that up, do you see what's left? I have 2x equals 4. So that's going to be my first equation. 2x equals 4. Okay, well then let's say I did and we still have to solve that, by the way. I'm just having you guys set it up first. Let's say we did the same thing for the x. I put a 0 in for x. Note that that negative still sticks to the y. So if I put a 0 in for x, I get negative y equals 4. Okay, so I need to solve those, but it's a little bit easier than writing out all the substitutions and all that. So think about this one. This means times by 2. So the opposite of times by 2 would be divide by 2 on both sides. So we get x is equal to 2. And remember, that's not the vertical line, x equals 2. That's 1 point. That's when y equals 0, x equals 2. So I'm going to put that dot. X is 2 when y is 0. Okay, now we're going to do the y-intercept. The y-intercept, y is almost by itself, but there's still that negative. You have a couple options. You could just switch the signs on both sides. Mathematically, sometimes I'll tell my students just divide by -1 on both sides or times by -1 on both sides. Essentially, that will switch our signs for us. And so now y is completely by itself because we want to know what positive y is equal to. Well, positive y is equal to -4. And again, that's just a point. That's when the value of x is 0, y is equal to -4. It's not always equal to -4. It just happens to be when x is equal to 0. So here's what our line looks like. You just connect the dots. That part's kind of fun, right? All right, let's do a couple more of these ones. Again, cover-up method. If I plug in a 0 for the y, boop, what does x equal? I hope you said -6. Maybe not out loud. That would have been a little weird. But so x equals -6. That one's already solved. So we're done with that one. x equals -6, 1, 2, 3, 4, 5. It's going to go out there. I'm going to write it -6, and the value of y was 0. We're going to plug in over here. If I cover up the x, and mathematically, I'm substituting 0 for x. Cover up is not a mathematical operation. So I'm plugging in 0 for x. So what we have left is 3y equals -6. I'm going to divide by 3 on both sides, so I get y is equal to -2. So I'm going to graph that one also, and I'm going to put the coordinates for that point. That is over 0 and down 2. So I'm going to connect the dots, and I'm done. Boop. And you have to make the sound effects too. All right, question number 4. So, wrong pen. We're going to do the same thing. If I plug in 0 for y, essentially that goes away. So what we're left with is 5x equals -10. So I'm going to write that. 5x equals -10 when the value of y is 0. So divide by 5 on both sides, so we get x equals -2. I'm going to graph that one, x equals -2. The coordinates for that would be go backwards 2, go up 0. The next one, if I plug in, and be really careful with your signs on this one, if I plug in 0 for x, I get -2y is equal to -10. And then remember that we would divide by -2 on both sides. So y equals a +5. So 1, 2, 3, 4, 5 kind of messes with that other line right there. And the coordinates for this point are over 0, up 5. And then if I want to graph that line, it looks like that. Okay. The next ones are even quicker, and then we'll get started on your homework. Okay, so look at number 5. Where's the x, right? If I plug in 0 for x, there's no place to plug it in. So this just tells me that y is always equal to 4. So first we're going to find that. Here's the y-axis. Here's 1, 2, 3, 4. Okay, well, if y, no matter if x is 1, y is 4. If x is 2, y is 4. No matter what x is going to be, y is always going to be equal to 4. It crosses through the y-axis at 4. So through y at 4, and it's a horizontal line. Okay, if we have x equals, and this is not like that one. This is referring to a point. This has an equation. That's the value just at that one point. This is the whole equation. This one's telling us x is always equal to -2. No matter what y is, x always, always, always equals -2. So let's look at what that would be like. Let's first of all find, here's the x-axis is the one that goes side to side. Whoops. And then x is equal to -2. Well, there's -2. Well, if y is 1, x is -2. If y is 2, x is -2. X is always going to be -2. So it looks like a vertical line. It passes through the x-axis at -2. Okay, so those ones are pretty quick to graph as long as you know what you're doing. Okay, so now on to the homework. We are just going to go over the odd problems. You are responsible for all of them, but I will help you out with the odds, and then hopefully that's enough information for you to be able to do the evens as well. So try your best on those ones. You still have to do them. Okay, question number 1. This one we will do together. So graph the linear equation. So I'm going to start by writing out my 2 equations with the cover-up method. Again, mathematically, cover-up is not an operation. What we're doing is we're substituting in 0 for y. When y is equal to 0, that part goes away. 4 times 0 is 0. So I don't even have to write it. So I know I can just start with that next step, which is 5x equals 20. And then I know, divide by 5, so x is equal to 4. I'm going to plot that. And then I'm going to do the y value. So if I put a 0 where x is, then I would get 4. And if it's a positive, we don't have to write the plus. But if it's a negative, that negative sticks to it, right? A positive 4 is still positive 4, even without the plus. So 4y is equal to 20. Divide by the 4 on both sides. So y is equal to 5. So I'm going to graph that one. 1, 2, 3, 4, 5. And then we're going to connect the dots. And we're done. Okay, so you guys try that one on your own. Remember, cover-up method. you're going to write out, that's going to be your first equation. That's going to be your second equation. Plot those 2 points, connect the dots. Okay, question number 3. We're going to do that one together. So we're going to start with the x's. So I'm going to put a 0 in for y, and then that goes away. So I have 10x is equal to 10. Divide by 10 on both sides. So x is equal to 1. 10 goes into 10 one time. So I'm going to put that dot on there. Then I'm going to do the y's. So I'm going to put a 0 in for x, and that part's going to cancel. Well, it's going to multiply by 0, which is just 0. And so I'm going to write 2y is equal to 10. I'm going to divide by the 2, so y is equal to 5. So I'm going to go to the y-axis. I'm going to go to positive 5, and then I am going to connect the dots. Okay, more practice. You guys are going to do problem number 4. You're going to do that one just like problem number 3. Just a reminder, make sure you're very careful with the negatives here. A negative divided by a negative is a positive. Okay, we're going to do question number 5 together. So I'm going to put 0 in for y. So I get 4x is equal to negative 12. I'm going to divide by 4 on both sides. So I get x is equal to negative 3. Here's the x-axis. Here's the negative direction. Then I'm going to do the y. So I'm going to put a 0 in for x. And then I get 6y is equal to negative 12. So divide by 6 on both sides. So y is equal to negative 2. And then we're going to connect the dots on those ones. Okay, you guys are going to do this. Oh, no, just kidding. Number 6 is not like the other ones. Okay, this is like what we did in the practice, where that's the whole equation, you guys. It's going to pass through x at 4. So boop, vertical line. Question number 7, it's going to pass through the y-axis at 2. So that one is a horizontal line. Remember, if there's not x's and y's, it's not going to be a diagonal. If there's only x's or only y's, it's going to be either straight up and down or side to side. Okay, so for question number 8, that one would be just like it, but instead of positive 2, it'd be down to negative 3. For question number 9, we have an x equals. So I'm going to find negative 1 on the x-axis. Remember, x is the side-to-side axis, and it's going to pass through at negative 1. But if it's going to pass through the axis, it has to go perpendicular to it. It's going to be going up and down because x is always equal to negative 1. And you'll remember from last chapter that this is not a function if it's a vertical line. Okay, question number 10. You guys are going to do that one on your own, but just take a look at it. This one says describe and correct the error. Well, they found the x-intercept, which is a value of 8 and a y value of 0. And they found the y-intercept, which when you plug in 0, you get a y value of 2. Try to figure out what their mistake was. Do these form one point, or do they form 2 different points? So write that out in your own words and fix their mistake. All right, that is it for today. Sorry, this was kind of a long lesson. Thanks for hanging in there, guys, and we'll see you next time.